So in this question, we have an elastic collision of two bumper cars. And we know their mass and respective velocity before the collision. We want to know their velocity after the collision and the change of momentum of each. So let's first try to figure out their velocities after the collision. So two equations we have for elastic collisions. The first one is the relative velocity equation. So this is the equation 7.7. So this formula says that the relative velocity of two objects will be equal and opposite before and after the collision. And the second formula we need is the formula for conservation of momentum. So MAVA plus MBVB equals, so momentum afterwards is MAVA prime plus MBVB prime. So these two are the formulas we will need. And we have two formulas and two unknowns, VA prime and VB prime. So the first step is always to use the first formula to cancel one of the unknowns in the second formula. So here I will express VB prime in terms of the rest of the quantities. VB prime equals VA minus VB plus VA prime. And then I will substitute this expression into the second one. So I have MAVA plus MBVB equals MAVA prime plus MBVA minus VB plus MBVA prime. So now I arrange everything to have MA prime on the left hand side and the rest on the right hand side. So this gives us VA prime equals MAVA plus MB. So this is 2 times VB minus VA. And divided by MA plus MB. Now we plug in everything. We have MAVA is 435 kilogram times 4.50 meters per second, plus MB is 495 kilogram times VB is 3.7, so 2 times 3.7 meters per second, subtract 4.5 meters per second. So it's 7.2 minus 4.5, 7.4 minus 4.5, which is like 2.9. So divided by the sum of them, 435 kilogram plus MB is 495 kilogram. Okay. So after putting everything into the calculator, we get 3.65 meters per second. This is the velocity of car A after the collision. Now we have VB prime equals VA minus VB plus VA prime. So 4.50 meters per second minus 3.70 meters per second plus 3.65 meters per second. And this is 4.45 meters per second. Great, so that is the velocity of A and B after the collision. And they are both still moving in the same direction as previously because both of them are still positive values. Okay, second, we are asking what is the change of momentum for each. So let's first do it for A. A, we can see it slows down a little bit, so the momentum we expected to be negative. Delta PA is delta P final minus delta and minus PA initial. So this is mass of A times VA prime minus VA, which is 435 kilogram times 3.648 meters per second minus 4.50. Actually, I didn't take that many significant numbers previously. So 3.65 meters per second minus 4.50 meters per second. This gives us negative 370 kilogram meters per second. So this is a change of momentum for A. Its momentum decreases by 370 kilogram meters per second. We can calculate B by the same way, using the mass of B and the velocity of B before and after the collision. Or we can just say delta PB equals negative delta BA equals 370 kilogram meters per second, because the momentum is conserved, so the change of the momentum for A and B must be equal and opposite. So so we know the velocity of each car after the collision, and we know the change of momentum of each. A decreases by 370 and B increases by 370, and the total is still conserved.